diagrams 1 and 3 in terms of conservation of energy. Okay? So we have the equations that we talked about at the beginning of class. It says we have one type of energy at the beginning, and by the time we get to the end, what's going to happen to that energy?
It's going to be the same.
It's going to be the same.
The quantity is going to be the same, but what happens to the format?
It's going to be dispersed.
It changes. Okay, so we are going to literally translate that into an equation. Okay, so if I take the equation that I have at the beginning, so what equation do I have for diagram 1?
The gravity.
Potential gravity.
Okay, and what is that equation?
9.81
mgh.
That is a constant value for the acceleration from gravity.
Yeah.
We're talking about potential energy due to gravity. Okay. Where's your pencil? You guys have a pencil, but you can write on your own paper. So we want to translate this into an equation. So then, okay, hold it and put it on this paper. So we want to take the equation from over here. So what is our beginning equation for diagram? MGH.
mu of gravity.
Okay, that's going to be our initial amount of energy. By the time it gets to the end, it changes into what?
String and
Okay, so what are our two types of energy we have at the end?
string and gravitational.
Okay, write them down.
We just like searched for Oh, so you were right.
And it says for each diagram.
Nice. Until the next question.
And you do take that minus that. Yeah.
That'll work.
Yes.
Okay, so we need to be able to set these equal to each other because we have conservation of energy.
Yes.
Okay, so this is going to be our left-hand side of our equation because that's going to be our initial energy.
Oh yeah, we have
Is equal to our right-hand side of the equation, which is going to be the total of all of our remaining energy. Okay, perfect. Now, are these two H's the same?
No, they're different.
What does that one stand for?
The initial height,
Right? And what's the one at the top?
the final height.
Final height. Okay. Do we know this information?
Yes.
We know all of that. Do we know this information?
Yeah.
Okay. What about the K and the X?
We know K, we don't
T is
know.
equal to.
We know K?
K is the stretchiness.
It is, but look at here. We're talking about the next step, and you guys are fine so far. But okay, so this is what we have. Let me show what he said. So we said we know this entire quantity. You guys already punched it out. We know this quantity, MGH at the bottom, because you're going to decide what your final height is. What's your final height in your group?
We haven't really decided one yet.
We got 5 centimeters. Yeah,
5 centimeters. You guys want to be more daring or less?
4.
4.
Oh, okay.
All right. Okay, so then the only thing we don't have decided is what our K and X value is. Now, do we know how far the egg is going to pull it when it goes outside?
No.
No. But you did make this nice little graph, okay? And what you notice about your K on your graph is that K is changing all the time, right?
Yeah.
Okay, stop there. Okay. Something seems funny about your numbers, so I'm going to
We
double
had
check.
one moment where it went down at one point, but I think that was because of human error with our pulling. Something moved.
No, you have like a start of a thing and then it starts over.
Yeah, like we went back down at one point.
Okay, so but what I can decide is, let's say I think that my egg is going to pull it 1 meter exactly. Then what would my K be that goes with that 1 meter? If my X is exactly 1 meter, what is K? According to your graph, it's 3. Okay, yours is not going to be the same because you have different rubber bands. So, but I can plug them both in. And so if I say if X is exactly 1 meter, then K is equal to 3. So then if I plug that in, what should happen to these two sides of the equation? They should be equal. If they are not equal, then that's not how far the egg is going to be stretching your rubber band. Okay? So because they're both changing and I have two unknowns, the only way to do this is through iterations. Okay? So I'm going to pick a starting point. It's going to be big. It's not going to stretch at just 10 centimeters. It's going to be closer to a meter. A meter's probably a good place to start. So if I punch that in and I find out this side is bigger than this side, then what should I do with my K and X values? 24. I need bigger or smaller ones. I would need to go down. If I find out this size is big enough, I need to go up in my graph. Okay?
Yes.
All right, so that's your next step. Now, once I've done those two things, let's look at my original diagram. Once I know how far my X is going to stretch, how far my rubber bands stretch, then I can find how much string I actually. Then I will have my entire budget. Sound good?
Yes.
All right. Don't forget. How long is that?
Oh, we met
18.7.
18.7 what? Centimeters. Is that going to be important? Yes, because if I left that off and I got an extra 18.7 centimeters of string. Bye-bye, little leg.
We want to protect it. So.
Bye-bye, JS.
You're wrong.
How are we doing? When you get to your answer, then I want to just double check it before I cut your string.